Welcome to the video series on the Vermont Green Streets Guide, a resource for planning and building green infrastructure within our communities. In this video, you will hear Sophie Sauvé lead you through Section 5, Green Street Design Principles. This section addresses both environmental and physical design considerations.
Physical considerations include driveway locations, utilities, existing trees, commercial storefronts, too much stormwater. Environmental considerations include topography and slope, soils, and winter climate constraints. A physical consideration impacting the design of a green street is the location of driveways. Like any street, green streets must accommodate access to residential and commercial driveways. However, closely spaced driveways limit opportunities to implement green street design elements by breaking up linear green buffers while posing increased risk for pedestrians and cyclists. Consider an access management plan that consolidates closely spaced driveways and incorporates adequate areas for vehicles to safely enter and exit without damaging adjacent stormwater landscaping. Another physical consideration is utilities. Above and below ground utility conflicts are among the most commonly perceived physical constraints to implementing green streets projects. However, utilities and stormwater systems can coexist with the right site conditions and stakeholder support. Understanding and communicating different approaches to dealing with potential utility constraints is critical as they range in cost and complexity. Where overhead utilities are present, carefully consider a plan for the mature height of selected shade trees to avoid conflicts. Be aware of minimum required step-back distances for maintenance of above and below ground utility infrastructure early in a green streets effort. Work to avoid potential conflicts associated with subsurface saturation by prioritizing alternatives such as line filtration units where there is concern. Pervious pavers and low expenditure landscape stormwater systems may reduce the cost of underground utility access for repairs, as they are easier to remove and replace than traditional hardscapes. Another physical consideration in designing a green street are existing trees. Construction of green stormwater infrastructure adjacent to existing trees should preserve the integrity of the soil and roots within the tree's critical root zone. At a minimum, this is the area under the tree's canopy. Although many tree species will benefit from the increased availability of water, some species may not respond well to a sudden influx of stormwater at the root zone. Consult with a qualified arborist when planning new green stormwater infrastructure adjacent to existing trees. Another physical consideration are commercial storefronts. There may be a concern that new landscaping will obscure the visibility of their storefront, compete for valuable sidewalk space for signage or pedestrians, or inhibit an ability to provide ADA access to a store. Additionally, new stormwater management approaches may be perceived as potential causes of ponding or damage to existing built infrastructure. Any infrastructure placed within 10 feet of a building foundation should not promote water migration underground. Line filtration practices with underdrains or container landscaping will capture rainwater without diverting it toward building foundations and can safely and effectively be employed in space-constrained downtown locations. Another physical consideration when designing a green street is too much stormwater. Large parking lots and broadly paved downtown areas generate a large volume of stormwater runoff. Using a decentralized treatment approach where multiple small practices installed evenly throughout the landscape manage the water volume incrementally can create a bigger impact combined compared to large individual practices such as detention ponds that are less effective at mimicking natural hydrological conditions and require extensive maintenance time and equipment. Some environmental considerations which are unique to Vermont include topography and slope. Here in our state, where steep slopes can express the character of a town, topography can be a challenge and an opportunity. While the flow of stormwater should be expected to be more rapid and efforts to infiltrate must consider a terraced approach to allow sufficient time for water to move into the soil profile, other factors need to be taken into account in the design stage, including slope stabilization and vegetative cover. Vegetative cover at multiple levels, from canopy to ground cover, is a highly effective method for ensuring stable green spaces on slopes. An additional environmental consideration when designing a green street is soils. The structure and composition of soil affects vegetation success, as well as the types of structures that can be installed and the capacity of water to penetrate the ground. Urban soils can be challenged by human influences such as compaction, salt addition, industrial pollution, and hydrologic alterations from development. All rooted vegetation receives nutrients, water, and stability from the soil. No matter the species, successful plant growth requires access to sufficient soil volume with the necessary amount and ratios of these necessities. Vegetation types vary in their specific requirements regarding space, water saturation tolerance, and chloride sensitivity. When selecting species, their needs should be considered in relation to the site's soil characteristics. Minimize soil amendments required for plant establishment to avoid adding excessive nutrients that can leach from the landscape, particularly if the vegetated area is used as a focused stormwater practice, and negatively impact water quality. In locations where soils are contaminated with pollutants, are excessively wet, or exhibit slow infiltration rates, green infrastructure selection should reflect the challenge. With regards to soil, it's also important to consider the soil's hydrologic group. Soils are classified by hydrologic group based on how readily they infiltrate water. Soil hydrologic groups A or B denote high infiltration rates and low runoff potential. These soils are mostly deep sands and gravels and are ideal sites for infiltration practices and can accommodate large volumes of water over short periods of time as a result of their physical characteristics. Soil groups C or D are characterized by slower rates of infiltration due to finer soil textures, chiefly silt and clay, and an impediment to downward water movement, often from either a high groundwater table or a subsurface clay pan restricting flow. While not ideal for infiltration practices, soil C and D can be effective sites of filtration practices such as gravel, wetlands, and lined bioretention areas. Planting trees, shrubs, and other plant material with extensive root systems can help loosen tight soils, provide more infiltration capacity and capillary storage space, and allow for greater evapotranspiration of water. Green street designs in groups C and D soils can also incorporate additional draining components, such as underdrains, to account for the limited infiltration capacity of the native material. In terms of soils, it's important to be aware of hazardous materials. Know the history and prior uses of a site before determining the safety of a stormwater infiltration practice. Consult municipal records and prior deeds, and if contamination is suspected, test soils for any hazardous materials. Per the Vermont Stormwater Manual, areas with concentrations of hydrocarbons, trace metals, and other contaminants above those found in typical stormwater runoff are referred to as stormwater hotspots. So hotspots include areas where there is a potential risk for spills, leaks, or discharges, such as petroleum distribution centers, hazardous material loading and storage facilities, and many other industrial sites. Due to the threat of pollution migration and to prevent groundwater contamination, stormwater that encounters hotspots should not be treated with stormwater infiltration practices. The Vermont Agency of Natural Resources hosts a geographical tool, the Natural Resources Atlas, that can help identify hotspots if it's adjacent to the dry cleaner or has a land use restriction associated with the property, as well as any other sources you've provided. From the atlas, open the Waste Management layer and select the following categories: landfills, land use restrictions, hazardous sites, hazardous waste generators, brownfields, salvage yards, AST, UST, dry cleaner, and urban soil background area. One of the most important factors to consider in a green street design with vegetation is available soil volume. The problem with traditional tree plantings and sidewalk cutouts along streets is that they typically have very limited soil volume that lead to stunted growth, sidewalks heaving due to constricted root growth, and shortened lifespan. A tree's ability to grow and thrive is largely dependent on available rooting space. Trees need at least 1 to 2 cubic feet of soil volume for every square foot of crown area projection. For columnar or fastigiate trees, which have a narrow overall crown area, the diameter at breast height, or DBH, should be used to estimate soil volume needed for a specific tree. An important environmental consideration for Vermont green streets is the winter climate. Vermont's winters can limit certain green street applications, but clear knowledge of thresholds and careful planning can safeguard success. Identify the soil's frost depth and install below it. For most of Vermont, the depth of frost protection is 5 feet. Similar to designing footings for retaining walls or stairs in our winter climate, footings in any inlet or outlet pipes in stormwater basins need to reach below frost depth. If not properly located below frost levels, they can freeze and cause water to bypass the practice untreated or to crack and cause maintenance problems. Additionally, any low flow orifice can become clogged with ice, potentially causing flooding. In our winter climate, it's also important to verify plant hardiness zones and avoid planting salt-intolerant species directly adjacent to roads. Note that salt can damage vegetation and soil structure, creating less permeable soils and further reducing the effectiveness of any practices located near the road. In vegetation filtration practices adjacent to road surfaces, select road de-icing practices less likely to cause damage. Discussing the reduction of salt use and alternative approaches to de-icing in combination with a green street is essential. In our winter climate, it's also important to carefully consider the limitations of permeable pavement. The use of sand on permeable pavement can eventually clog the pavement and the subbase below, rendering the system impermeable. Limiting the use of permeable pavement to areas with low traffic volumes that only use salt for de-icing, have good drainage and enough storage capacity underneath is essential but not impossible. In the winter climate, it's also important to understand the restrictions of road and sidewalk removal equipment. Adding mediums or stormwater bump outs may require a different approach to snow plowing and in some cases require different snow plowing equipment. Municipal public works staff may need training to anticipate changes on roads with traffic bump outs, especially during winter months, to avoid damage to new curbing and to avoid storing snow in green stormwater infrastructure areas. Trees along the street may also require special protection during the winter to protect from mechanical damage from the plow or other snow removing equipment. Permanent or temporary guards may be installed. Plan for street sweeping soon after the snow melt in the spring. Street sweeping will help reduce the volume of sediment that gets carried to conventional systems. Street sweeping can also be undertaken after intense storm events to prevent additional runoff from erosive material. Thank you and happy designing!
Thanks for watching. Next up, you will hear Becky Tharp lead you through Section 6, Green Stormwater Management Tools.